Welcome. This would be the first video of a series of videos I will be posting based on the Cisco NetAcad or Network Academy Introduction to Network course set. You can register for these courses through your local academic institution or accredited organizations to obtain Cisco NetAcad certifications. It can be CCNA or CCNP. In this particular slide set, we will be learning about Introduction to Networks, Module 1, which is part of the CCNA. In this module, we will learn about how network affect our lives and explain how network can be useful or being used in our daily lives, the network components, explain how the host network and devices are used, the network representations and topologies, in other words, how the networks are represented on paper and on electronic documents, common types of networks and their characteristics, the internet connections such as LANs and WANs and how they interconnect, reliable networks, which describe the 4 basic requirements of a reliable network, the network trends such as how the bring your own device, online collaboration, video, cloud computing, such those new concepts come into play. Network security, some of the basic security threats and solutions that we have in our systems. And finally, the IT professional, which explains some employment opportunities in the networking field. You will be most likely taking these courses hoping to find a job in the network engineering or network analyst sector. So that what we will discuss at the very end a little bit in this particular module. Network affect our lives. The communication is almost as important to us as air, water, food, or shelter, especially with the global pandemic that we have experienced last 2 years, with COVID-19 affecting in-person workforces. A lot of people, you probably work from home because of it. As a result, all of us, even who are not in the IT industry, probably been exposed more to the IT industry and network engineering last 2 years. We are connected like never before. Our future generations will be more connected than our current generations, and we are more connected than our previous generations. Especially during the COVID-19, what had happened is actually this type of interconnections through network systems have gone into override. As more and more companies have been forced to send their workforce home and yet have the ability for those workforce to contribute from home is based on the network systems and communication infrastructures we use today. The network system therefore allow us to create a world without boundaries. It creates global communities and it creates human networks. You could work from anywhere in the world for some companies where you can connect it to their network through VPN and other services, and you would just be as working if you were working from their head office. For example, imagine you have a company in Calgary, Alberta, Canada. But imagine you are in Houston, Texas. You can access your Calgary head office through a VPN system, and basically you have taken down global world boundaries. You can be part of the same workforce as the Calgary workforce, even though you are located in Houston, Texas. So that's one of the things the network systems can do today. The network systems have some components. These components are defined based on our ability to understand the infrastructure of networks and how we have decided to put together the global communication network systems. The network components includes things like host roles, so that every computer on a network is called a host or an end device. Servers, on the other hand, are computers that provide information to the end device. Servers can be email servers, web servers, and file servers. Another typical identification of what defines a server is that servers are typically accessed by multiple clients, while the client computers that send requests to the servers to retrieve information. These could be web pages from a web server, such as an HTTP or HTTPS request, an email from an email server. Email servers run email server software. Therefore, the clients and the client software can access those emails, while the web servers can run websites with that particular software modules, where the clients can request HTTP or HTTPS request to that web server and take that and get that web page displayed on their end, while the file servers stored information in specific or multiple different file formats that the end user can access. In a one particular server, you could have multiple of these services running. You could have one single server with the email, web, and file, all three services running at the same time. And we will go into depth on our future videos on how that works. Another network component is client and server, how they interact with each other. A computing model where the server software runs on a dedicated computers are called servers, such that the server component contain those email servers, web servers, and file servers. While the clients are, as I mentioned on my previous slide, are the one that actually requesting those information. So that is a really good definition. So you should remember that. A computer team model where server software runs on a dedicated computers. And those dedicated services that providing those services, such as email and web and file servers, are called servers. While the client are the end devices that requesting those services from these servers. Another network component called peer-to-peer networks. Peer-to-peer networks pretty much have no control by a central authority. There's no central control in that peer-to-peer networks. No privilege over anyone, and it's varied and usually unsafe and unsecured. The reason why the most corporate networks will not use peer-to-peer system is basically the security and the control is not there. The peer-to-peer must have the exact same operating system in order for them to communicate with each other. In terms of scaling, the peer-to-peer network cannot be scaled up. Typically, they are only used for sending data directly to a printer or directly to a particular end device that specifically need that peer-to-peer connection. In modern day, most organizations and companies would not use it. However, they do have some advantages. As I mentioned, it is easy to set up, less complex, it costs far less than running a server, and it can be used for simple tasks. Disadvantages, as mentioned here, is there's no centralized administration, it's not secure, not scalable, and slower performance. The end devices, the network components that are considered as end devices, is where messages originates from or where it is received. If you are sitting in front of a computer right now and it is connected to a network such as your home network or your office network, you are actually using an end device, which is defined by network engineers as an end device to access data. The data originate with an end device, flows through the network and arrive at another end device when you submit that data across the system. For example, if this user send an email from his end device, it goes through this network and email servers and eventually will arrive at the intended recipient, which also will be using an end device, which is going to be a computer or a laptop. The next network components could be categorized as the intermediary network devices. These intermediate network devices interconnects end devices. These include switches, wireless access points, routers, and firewalls. They are used for management of data as it flows through the network is also the role of the intermediary devices. They are used as devices that do management of data as it flows through a network. They also include actions or they also do things like regenerate and transmit data signals, maintain information about what pathways exist in the network, and notify other devices of errors and communication failures. On our future videos, we will look into how the network tables work and how they switch packets between these devices. But for now, just remember these intermediary devices are very important because they basically manage the data as it flows through the network. And it makes sure that the end user from one end will get exactly what they want, and the end user on the other end will receive exactly that being sent. Finally, another network component that we should be paying attention to and often get forgotten is the network media. The network media allow communication across networks through a medium which allow messages to travel between source and the destination. In the old days, most of the network media was made out of metal wires. Even today, most of the homes have Cat5 or Cat6 cables, which are made out of metal wires. Modern high-speed network communication systems includes also the fiber optics or glass or plastic fibers, which is light pulsating across that glass medium to send digital data. They are faster, they are more reliable, and they are more secured. Finally, another medium that we use today is the wireless transmission. They use the modulation of specific frequencies of electromagnetic waves to send data between different clients and end devices. Wireless data transmission is not as secure as, let's say, the fiber optics and more prone to errors. However, they are easy to set up and they are very flexible, especially in environments such as if you have a large number of guests arriving at a place such as a hockey arena, for example. It is a really good option to use. At home, your devices such as your cell phone probably or most likely be using right now the wireless networks to communicate with the outside world. Let's look at the network representations and topologies. Network diagrams, often called topology diagrams, they use symbols to represent devices within the network. which make it easier for network engineers and network technicians to understand what's happening within a network. The important terms that you should know is the network interface card, or NIC, which is basically a physical connection port that allow you to connect to the network, and the physical port itself, which contain within typically the network interface card and the interface itself. Often the terms port and interfaces are used interchangeably because, as I mentioned just a few seconds ago, the physical port and the interface and all of these items typically associated with the network interface card. And if you look at on your right hand side, you'll see some common representations of end devices such as desktops and laptops and wireless tablets, and intermediary devices such as the routers, switches, and the network media such as the LAN Ethernet connections, wireless media, and WAN connections. These symbols are typically used on the Cisco packet tracer software, and we will look into that packet tracer software on our future videos. There is one video posted, there's actually a couple of videos posted on my YouTube channel that talk about Cisco packet tracer. You can look into that as well. It shows you how you can download the Cisco packet tracer and set it up. And these would be the symbols that we'll be using in the Cisco packet tracer labs. We'll be doing in the future when you try to set up lab environments. And those lab environments on Cisco packet tracer is using the topology diagrams and symbols to represent these different devices. The network topology diagrams can be put it into two different categories. One called the physical topology, the other one called the logical topology. The physical topology diagrams illustrate the physical location of the intermediary devices and cables installations, while the logical topology diagrams illustrate devices, ports, and addressing schemes of the network. I know this can be confusing for someone who is new to network engineering, but this is a really important concept that you should understand. This is being used almost everywhere to describe different aspects of your network engineering environment. So if you look at the diagrams right here, both left and right, these are the exact same network configurations, but described slightly differently. On the left hand side, you see the physical topology diagrams. So you have the internet, you have a router, and you have a bunch of switches, and you have end devices such as the email servers, web servers, printers, and users. This is a physical topology diagram because the areas are defined based on the types of devices, but the highlight here is the physical location of that device. For example, we have a switch here, router, and another switch and bunch of servers, but it is located at the server room. So we have lumped them all together with this yellow box as a server room for that those devices. And then this room 2124, we have bunch of switches, nothing else. So we lump them together like that. But if you look at the logical diagram on the right hand side, this network is separate from this network. It is separated by this router. So even though this router is located in the exact same server room as this switch and these end servers, logically this router has separated this section of the devices from that section and all of that section as well. And this router also separated this section from rest of the sections right here on the left hand side. And this separation start right here instead of starting here, because these switches are within this side of the router. So for example, this G01 is part of the, G01 contain the S3 switch as well as this end device. But G11 contain this S4 switch and this end device. And the primary responsibility of this particular a router is actually to logically separate these different sections. I will discuss and go into depth into how routers separate network topologies on our future videos. But for now, just remember, a physical topology based on the actual physical location of the device, and the logical topology is based on how the router or a particular network device separates the other devices, regardless of where the device is located. And we'll go into the next topic, which will be the common types of networks. So what are the common types of networks you will come across in 2022, the modern day? There are a couple of common types of networks that we typically identify. There are small home networks, SOHO networks, or small office, home office networks. Medium to large networks, seen typically on private companies, small companies, as well as government agencies with a particular specific location. And worldwide networks, such as a large interconnected global networks, such as probably like shipping companies, for example, have them all the way to credit card companies and the internet. Small home networks connect a few computers to each other and the internet, such as your desktop computer, your laptop, your cell phone, through your router and through your modem get connected to the internet. Small office or home office or SOHO networks enable computer within a home or remote office to connect to a corporate network. It is very important you understand the distinction. The small home networks connect a few computers to each other and directly to the internet. Small office, home office, or SOHO networks enable computer within a home or remote office to connect to a corporate network. It could be multiple computers or multiple devices. It just let those devices within a home or remote office to connect to a corporate network. This is a very important concept that you understand the difference between the small home networks as well as the home office network. This question often shows up on your Cisco NetAcad exams as well as CCNA and CCNP exams. So make sure that you understand the differences between the small home networks and small home office networks. The next one is the medium to large networks, which are many locations with hundreds of thousands of interconnected computers would connect together, would result in a medium to large networks. For example, if you have a company in Calgary and you have offices in Edmonton and you have another office in Vancouver, interconnecting them together would create a medium to large network. And then finally, we have the worldwide networks, which interconnect hundreds of millions of computers worldwide, as I mentioned before, such as credit card companies and global shipping companies, for example. They have their networks worldwide, but that also include the internet itself. The common types of networks can be categorized into two different categories, one called the LANs, the other one called the WANs. LAN stand for local area network. WAN stand for wide area network. Just exactly what it sounds like. It provide the network infrastructure to either a smaller area or a wider area. The network infrastructure vary greatly in terms of the size and the area covered, the number of users connected, the number and the types of services available, such as web services, internet, email, or just one of those services or multiple. An area of responsibility, such as within a country, within a city, within your own company, within your own home. Most two common types, as I mentioned before, is the LAN and WAN. And the differentiation between the LAN and the WAN can be put together in like a network diagram format on the right, just like this on the right hand side. So the WAN would be like the cloud network that connecting everything, and the LAN would be those each site, such as the home office branch and the central, that could be your LAN segments. So not LAN segments, LANs. So a LAN is a network infrastructure that span a small geographical area. You have the end user, or you have the end devices. You have a router or a switch in the middle, and then it's connected to another device. So typically it's a switch. When routers are involved, where it's routing data between two different routers, between two branches, for example, it becomes a WAN. So remember, a LAN is a network infrastructure that spans a small geographical area, and the WAN is a network infrastructure that spans a wide geographical area. LAN interconnect a limited number of devices in a limited area, administered typically by a single organization or individual, and provide very good high-speed bandwidth to internal devices. WAN interconnect LANs over a wide geographical area, typically administered by one or more service providers, and typically provide slower speeds links between the LANs. The last point may be slowly changing right now with the advancement of fiber optics, with a very cheap fiber optic networks coming out in 2020s and 2022s, for example. But it's typically WAN is always going to be slower than LAN, because remember, you can have a local LAN network completely connected with fiber optics for cheaper than to try to connect large areas of networks with only fiber optics between different sites using the WAN. So they are typically slower speeds, but they are getting better. The common types of networks also include the internet. The internet is a worldwide collection of interconnected LANs and WANs. And LANs are connected to each other using WANs. And the WANs may use copper wires, fiber optic cables, and even wireless transmission to communicate with each other. Some people have asked me, like, how often the wireless transmissions are used when you go to the internet. While we do have global network of fiber optics systems across multiple different cities, countries, the wireless transmission is also being used to communicate between different sites and communities, even today. Even satellite communication systems that sometimes connect multiple different countries can be considered as a type of wireless network. So if you're accessing the internet, if you're watching this video, you may have fiber optics high-speed internet connection, but at some point on your network, it may be using all the types of communication mediums: copper wires, fiber optic cables, and wireless transmission. You may be using copper wires to access this video, but your service provider or internet company may be using fiber optics to transmit your request and data back and forth between you and their data centers, and maybe using a wireless communication systems, including satellite communication systems, to reach the Google servers that contain this video on YouTube systems. So when you're accessing the internet, you may be using all of the mediums to access that particular document, file, or video, or any other information. The internet is not owned by an individual group. However, the following groups were involved in developing and maintaining the structures on the internet. They include the IETF, ICANN, and IAB. For example, IETF is the Internet Engineering Task Force, and they were responsible for standardizing most of the network infrastructure. ICANN is the Internet Corporation for assigning names and numbers. They were responsible for things like the IP address assigning, as well as the global World Wide Web web addresses, such as, for example, Sanuja.com and the Sanuja.ca. All of these things are assigned by ICANN or ICANN accredited organizations. This kind of standardization will allow us to communicate globally without having any conflicts between different network systems. So what you need to remember is the internet is not owned by any individual group, but however, we do have groups that maintain structures on the internet so that we all can communicate without having conflicts between different systems. The common types of networks include the intranet, which only have the access between the company communication devices. Extranet, which include the customers, suppliers, collaborators, which may not be in the same area, same geographical area as your company. And the internet, which is the World Wide Web. The intranet is a private collection of LANs and WANs, which is internal to the organization, that is meant to be accessible only to the organization's members or others with the authorization. You can think of it as a network within a building or network within multiple buildings that is secured so that only people who have access to that building or people who have access to that network have the ability to interact with it. The extranet can be used by your organization to provide secure access to their network for individuals who work for a different organization. An example of this would be, imagine you are an oil company in Calgary, Alberta, and you have your head office in Calgary, and you have your workers across the province. And those workers may be using intranet. But let's say you have subcontractors working for drilling, and you have subcontractors working for geotechnical work, and you have subcontractors working for your engineering systems. And those subcontractors will get the extranet access. So these are two key terms that you should know for your CCNA and CCNP exams. So make sure you understand the difference between intranet and extranet. Intranet within the company, extranet allow outsiders to access your company resources. Next, we will look at the internet connections. There are many ways to connect to the internet. The most popular services most users at home may be using would be the broadband digital subscriber link, or DSL, wireless WAN, mobile services, as well as the cable internet services. Organizations that feed faster connections to support IP phones, video conferencing, and data storage may use much better connections, such as fiber to the site. But now in Canada, some ISPs do provide fiber directly to your home for home users. And then we have the business class interconnections. They are usually provided by service providers, and they include business DSL, lease lines, some known as like a T1, T2 lines, for example, Metro Ethernet, for example. And these definitions between what is being used at home, what is being used by organizations, what is being used by business class connections are kind of fluid right now, because the technology is moving at a very fast pace. And a couple of years ago, even like 5 years ago, you would not be able to get fiber to the home in Canada. But today, most parts of most major cities in Canada, you can get fiber directly all the way to your home. So in this particular slide, just remember there are different types of ways to connect to the internet, but these definitions may slightly change as the time goes by. The home and small office internet connections can be cable, DSL, cellular, satellite, or dial-up phones. Cable connections, which include the fiber networks, include other types of specialized cables, provide high bandwidth, always on internet offered typically by your television service providers. DSL include high bandwidth, always on internet connection that runs over a telephone line. The cellular networks allow you to have internet connections to your cell phones where there is coverage available, which is very versatile, especially if you are going somewhere outside and you're out of nowhere. It's very useful. And then satellite networks provide internet connections to rural areas, and typically by providing direct satellite connection between the satellite itself and your small office or your home. Finally, the dial-up telephone connections, very inexpensive, low bandwidth, but it uses that dial-up connection, which is not very reliable sometimes, to access the internet. Even today, there are some parts of the world, they still use the dial-up internet connections. So you should know how dial-up networks works and how it is being used and utilized by different users. But in countries like Canada, where we live, most of the internet connections are either cable or DSL and also cellular. Rural parts of Europe as well as rural parts of Canada, there's satellite communication being used as well. And with companies such as, I think Starlink, they have the option for end user to buy the satellite systems that you can just hook it up to your roof or something to get the internet in rural areas. So you should know all of these types, including the dial-ups, because they are still being used, including the older communication mediums. The business internet connections include, as I mentioned, the dedicated lease lines, which are like typically known as the lease lines. Some of them are like T1 or T2 lines, for example. There are reserved circuits within the service provider's network that connects distance offices with private voice and data networking. They are more expensive to buy, but it provide very high bandwidth and very high availability. Then we have the Ethernet WAN, which extend the LAN access technology into the WAN, allowing communication between two different sites belong to the same organization, for example. Business DSL is also an option which allow symmetric digital subscriber lines, which is SDSL systems, to communicate business data between different sites. And finally, we have also satellite, which also provide a very good connections where it is either needed or required due to remote locations. And what make a corporate business connections unique is that most of these corporate networks, as opposed to home users, require higher bandwidth, dedicated connections, and typically have managed services, such as they will have a specific, maybe dedicated line for VoIP only, or a dedicated line for web access or web systems, or where there are particular software systems. The converging network, Before converged networks, an organization would have been separately cabled for telephone, video, and data. So you'll have a separate video line, you have a separate telephone line, you have a separate data line. Each of these networks would use different technologies to carry the signal. Each of these technologies would use a different set of rules and standards as well. It would be really hard for these technologies in the old days to interconnect between them. For example, you can't have a voice or a video system communicating with the data system. But today, we have what we call the converged data network that carry multiple services on a one link. So you could have one single data link, like a physical link, that include data, voice, and video. Converged networks can deliver all of them on the same network infrastructure. The network infrastructure uses the same set of rules and standards. But how we actually make this thing work is we use things like VLAN, we'll use ACL, access control list, and we use a bunch of other methodologies or methods to make sure that all of this data is delivered according to how it should be delivered. Like for example, if you have a one link to deliver data, voice, or video, we always give priority to video and voice over data. Because a delay packet in data may not cause a major problem, but delay packet in voice and video definitely will create a problem. Such as, for example, one user may be speaking on this phone, and if the data is delayed to the next user that who is listening, that user may respond before the message being sent across. So we will look into depth how we use things like QoS, data tagging, VLANs to separate this network, even though we are using a one link in our future modules. But for now, just know that the modern network use converging systems. In this particular course, you will be using the Cisco packet tracer, because this course is designed by the Cisco for CCNA and CCNP. I will leave a link below to Introduction to Packet Tracer video that I created a few weeks ago that you can watch to learn how the packet tracer works. So I will just skip this slide. And if you want to know about packet tracer, how to download it, and some basic configurations, you can check out that video link posted below. The packet tracer software allows you to create network representation using those symbols that we discussed previously. And if you are registered for CCNA or CCNP studies, you will have some module labs that you can do to learn how it works. I will not show that in this particular video, but in the future videos, I may go into those examples of some of the packet trace activities so that you can learn some network systems and network engineering. And as mentioned before, when we do those labs, it's not important that you understand everything at the beginning, but as we move forward, you should be able to understand everything. So we'll move on to the next section in this module, which will be reliable networks. The reliable network architecture is based on how multiple concepts coming together to build a better system. So that's the best way I can explain it. So it's a network. So basically, the network architecture refers to the technologies that support the infrastructure that moves data across a network. And using 4 basic characteristics underlying that network architecture, we can create a reliable network. Those characteristics or concepts are fault tolerance, scalability, quality of service or QoS, and security. And on our next few slides, we will look into each one of them separately so that you will understand how all of these 4 concepts or characteristics come together to build a reliable network architecture. Fault tolerance, the first concepts in the architecture for reliable networks. So the fault tolerance network limits the impact of a failure by limiting the number of affected devices, by providing multiple paths that can be used to communicate between each other. Reliable networks provide redundancy by implementing a packet switch network, because in packet switching, it can split traffic into packets that can be routed over multiple channels or multiple paths, providing redundancy. So basically, each packet could theoretically take different paths to reach the destination. So imagine you are an end user right here, for example, on the left-hand side, and you send an email. That email may have multiple packets. So in a circuit switch network, it will go find one single path and it will go like this and then go to the end user like that. Or go like this and go to the end user like that. But in a packet switch network, what's going to happen is that data gets split into different packets and it will take this route and then reach the end user like that. And then the next packet can go in a different route and next packet can go in a different route. So imagine if this router was taken down or malfunction, but the first packet went through that router. That's okay, because the next packet will reach this router. It can't go any further, so it will actually go find the next router and go through this connection and reach the end user. This is not possible with the circuit switch network because it will be connected straight one line and then there's only one path between the end users. So packet switch network increase fault tolerance by splitting the traffic into multiple packets and sending those packets into different sending those packets to the same destination using different paths. The next characteristic of a reliable network is the scalability. A scalable network can expand quickly and easily to support new users and applications, also end users and end devices, without impacting the performance of the services to existing users. This is a very important concept. This shows up on exams all the time. So the scalability is not just plugging in a new device and it just works, but the scalability also includes that it is quick, easy to add that end device or intermediate devices without impacting the performance and services of existing users. That's what makes the scalability scalable. So the network designers follow accepted standards and protocols in order to make the network scalable. So for example, we have this network and the additional users and whole networks can be added to this particular network by simply adding a switch onto the router and that switch providing multiple ports for the end users. We will go into depth in our future modules, but just for now, just remember the scalability is not just plugging in a end device or an intermediate device into a system, but then impacting all the users on existing users. Scalability, a properly built scalable network will allow you to add those users and devices without impacting the performance or services currently being used by the existing user. That is a very important concept. And the next one is the quality of service. Quality of service is very important to services that cannot take latency or cannot tolerate latency or drop packets. These typically include the voice and live video transmissions that require higher expectations for those services being delivered. So if you and I are speaking to each other on a VoIP telephone and a couple of packets get lost not only you may not be able to comprehend what I have to say, the transmission may be like completely useless. Like it's not only create confusion between like IP phone users, it could actually be like completely useless at all. Like, so for example, have you ever watched a live video with constant breaks and pauses? For example, if you are accessing this YouTube video on your cell phone using a 2G or 3G network in a remote area in Canada, it may be buffering, right? So this is because it caused by high demand for bandwidth than the availability of the bandwidth in that particular system. And the QoS isn't properly implemented on some of the networks, which also resulted in the same thing. So for example, you will be watching a video, then suddenly someone in your house decided to download a large file, and if the QoS is not implemented in your home router or modem, what's going to happen is all those packets are going to be delivered between your video and the person who's downloading that large file. So your bandwidth will be split basically randomly. But however, the quality of service is one of the primary mechanisms that used to ensure the reliable delivery of those content for all users. With a QoS policy in place, your home router or your business router can provide more managed flow of the data and the voice traffic. So it can prioritize your video, or you can prioritize your VoIP telecommunication messages over somebody downloading a large file on the same network. And this is on the right hand side, it shows a small diagram. It shows the quality of service managed by a router. When VoIP communication is started, it gives the priority to that voice packet over somebody who is browsing the website, because website packets can be delayed. That should not have a major impact on your end user, but if the voice packets are delayed, like I said, it will be useless for communicating voice across the system. Another category that within the reliable network that is very important is the network security. There are two main types of network security that must be addressed. They include the network infrastructure security, physical security of the network devices, like such as the infrastructure includes anything physical, and it also prevents unauthorized access to those devices. So that could be a server room with a lock on it, or a server room with a special access control or security. Data centers, for example, used by governments and credit card companies, for example, they have military officers and security with even guns and very tough security to make sure that those data infrastructures are physically protected. Even Google data centers across the world have very high security with physical security personnel. So that would be the network infrastructure security. And then the second type is called the information security, which is the protection of information or data transmitted over the network. The protection of those data can be used can be done using things like encryption and authentication for making sure that data is accessed only by the persons who should be accessing, and then data when they've been sent over a network that are being encrypted and properly handled. So that would be the information security side of things. The three goals of network security is confidentiality, which means, as I mentioned, it's only intended the only intended recipient can read that data and also write that data as well. Integrity, in other words, it assures that the data has not been tampered or altered during the transmission. And then availability, such as that the data that needed to be accessed can be accessed a timely and reliable manner by all the authorized users. So for example, imagine you have a EMS emergency services network, right? So you need your EMS personnel to access all the medical data on the field. So if you make it super secured and super, highly, highly secured, but the data availability is very slow and can access in an emergency, if somebody having a heart attack, for example, and you need to know their medical history, doesn't matter all the security is there, the availability is not there, right? If that's the case, we will send mail between the EMS work site and the major hospital. So instead, we need to not only have that confidentiality integrity, but we also need to have that thing balanced with the availability of that data. Otherwise, that will be useless, right? So how this can be managed is by administrators protecting the software and hardware using like encryption, as well as like a logging authentication systems shown on the left hand side of this slide. Next, we're going to talk about the network trends. So recent trends in 2022, especially with the global pandemic, we saw the role of network have adjusted continually, especially during the last few years, to transform in order to be able to keep up with the new technologies and end users devices as well as the requirements. So the global pandemic provided us a really great example of how fast technologies have adapted to changing environments. Several new networking trends that affect organizations and consumers in modern day would be the bring your own device, or BYOD, where you can bring your own cell phone but connected to the corporate network to access corporate resources, including corporate software as well as specific applications. Online collaboration, where multiple users worldwide, globally, or it could be within a country also, collaborating with each other using an online platform. Video communications, such as conferences, especially during the global pandemic, during the COVID-19, we had few network engineering conferences as well as geotechnical and engineering conferences done all online, where everybody collaborated. And then cloud computing, which is things like, your Gmail, for example, is cloud. It's basically cloud-based. Office 365 from Microsoft, which is cloud-based. You can buy cloud services instead of having your own physical data centers. For example, if you have a small company, it may be beneficial for you to go with Office 365 in 2022 rather than actually trying to run a email server physically on your own location. That would give you greater reliability, greater availability, and also give you data protection in case of things like fire or something like that. So let's look at the bring your own device, which allow users to use their own devices, giving them opportunities and greater flexibility. Bring your own device allow users to have the freedom to use their personal tools to access information and communicate using their laptops, netbooks, tablets, smartphones, even e-readers. BYOD means that any device with any ownership, can be used by anyone, anywhere on your network, as long as they have the authorizations and authentications to access resources within your network. The other one is the online collaborations, which allow collaborate and work with others over network on joint projects. This is actually how the internet first started, when in the United States, a bunch of universities get together and they connected their network to collaborate on research projects, scientific research projects. That's basically how the internet started. And collaboration tools in modern day includes like Cisco WebEx, which is shown on the left-hand side right here. And it can be MS Teams, Microsoft Teams, Office 365, another great examples where everybody can edit the same file at the same time. That gives the users to instantly connect and interact. So it's not only just the video or audio platforms such as this Cisco WebEx, but also like collaborative documents, for example, such as Office 365. Collaboration is a very high priority for businesses in modern day, but also in educational research sector. Cisco WebEx Teams is a multifunctional collaborative tools developed by Cisco, the company that provide this educational module, and it can send instant messages, post videos, and links. And Cisco WebEx is used by large companies, large governments, organizations, and institutions, and it has all the security and other systems built into it. So it's easy to use and easy to deploy by most network administrators and system administrators. Video communication. The video communication is now becoming more important as we are working mostly from remotely. Basically there are video calls made to anyone regardless of where they are located, and video conferencing is a powerful tool for communicating with others, especially when you are doing research with other countries, or you have a company that located in Calgary, but you have branches in United States, for example. Video is becoming more critical requirement for effective collaboration sometimes, because you may have charts, diagrams, and actual physical devices or data that you need to show to the person on the other end. And Cisco Telepresence is one of those tools that allow you to do that type of video communication. If you like to look at a quick video on how Cisco WebEx works, like a basic advertisement kind of video, you can check it out on the Cisco official YouTube channel, and I will leave a link below, and that's the link here, but I will leave it in the description as well. And most modern upcoming, I would say, network trend is the cloud computing. It allows us to store our personal files or backup our data on servers over the internet. Applications can be used to access using cloud, allow businesses to deliver to any device anywhere in the world. In this particular module, I will not go into depth of cloud computing. I will discuss that in depth in a different module. But what you need to remember in cloud computing is that cloud computing made possible by data centers instead of smaller companies having their own small data centers or servers, like I mentioned before, such as a email server located in Calgary in your own office, versus having the email in the cloud with Office 365, for example. So smaller companies that can afford their own data centers, they can lease those servers, and it allows storage services and in large data centers. Google, Microsoft, IBM, they all have cloud services. And for this particular module, only thing you need to remember is it increased the reliability. It allowed the smaller companies to outsource pretty much, to give that service to the cloud infrastructure. So get that service from that cloud infrastructure so that they don't have to worry about running their own data centers and physical servers. And there are a couple of different types of cloud computing. Public clouds, which are available to general public through pay-per-use module or for free. And then we have private clouds, which are intended for specific organizations or entities such as governments or University of Calgary, engineering or research networks that could be considered as a private cloud. Then we have the hybrid clouds, which are made out of two or more cloud types. For example, custom, part custom and part public. Each part remain distinctive object, but both are interconnected using the same architecture. Actually, the University of Calgary example would be a type of hybrid cloud. So you will have the University of Calgary professors and researchers interacting on part of their custom cloud, and then you have a public cloud where University of Calgary have opened up to the general public and everybody else to access their hybrid cloud system to collaborate with their university professors and researchers. Custom clouds, which are built to meet the needs of the specific industry, such as healthcare, media, or oil and gas industry. For example, if you have a drilling site in northern Alberta and you have your head office in Calgary, Alberta, and you need to access that data, you can create a custom cloud network instead of just a direct link, which allow you to have a higher reliability. And those custom clouds can be both private and public. Public custom cloud could be a small rural town. I saw just on the other day on the news in rural town in Japan, they decided to create a custom public cloud to allow public schools to access information within their networks. So that would be a small, custom cloud. And in terms of technology trends in the home, smart homes technology is growing trend that allow technology to be integrated into everyday appliances, which allow them to interconnect with other devices. I have been automating my home with a bunch of automation tools using Z-Wave compliance systems. Just to turn on the lights, turn off the lights from my cell phone. I can check if my garage door is open or closed using my cell phone, for example. And modern day, we have ovens, for example, that might know the time to cook a meal for you by communicating with your calendar on what time you're scheduled to be home. So you put your food in one of those Samsung or LG sophisticated oven, and you leave for work, and when you come home it gets start cooking. There are also washing machines like that as well, and there are other smart home technologies that currently being developed for all rooms within the house, pretty much everywhere. And next thing we're going to discuss is the power line networking. Power line networking been here for a long time. I would say it's longer than the smart home technologies that we see today. It allows devices to connect to a LAN with data network cables or wireless communications that are not a viable option. So it allows devices that are far away from your network hub or router to be connected using power lines already built into your house, as opposed to you actually running a data cable across the living room floor, for example. It is using a power line standard adapter that a device that can connect to the LAN wherever there is an electrical outlet by sending data on a certain frequency. So it is using your electrical cables but using a different frequency on that cable to send that data. And power line networking is very useful when wireless access points cannot reach all the devices in the home, or there are dead spots, or you have a concrete thick wall that cannot pass through that wireless signal. That is really useful too. I don't typically use power line networking in a business environment because it is reliable, but it's not as reliable as a wired LAN network. But it is a really great option, especially for home or where places it is extremely hard to put those wires cables in. The next one is the wireless broadband. In addition to DSL and cable, wireless is another option to use to connect homes and small businesses to the internet. The more commonly found like this type of thing is most commonly found in rural environments, and wireless internet service providers known as WISPs can use those high-powered communication broadband towers to send those signals across a wide area, like large area, where their clients are at. Wireless broadband is another solution, in other words, for home and small businesses, and it uses the same cellular technology used by the smartphones, except it may have a higher bandwidth allocated to it, so that an antenna can be installed outside of the house, providing wireless or wired connectivity within the devices in that house. Next, we will talk about the network security. Before we talk about network security, we need to look at all the security threats. We need to understand what are security threats we have on a system. So the network security is a very important part of the networking, regardless of the size and the network. Network security that is implemented must take into account the environment while securing the data, but still allowing for quality of service that is expected of the network. Remember that EMS on-site responders, they need to have access to your medical data if you're having a heart attack as soon as possible, but still need to be secure that your personal information is not being leaked. So in network security, it is not only important that we implement the security, but we also need to make sure that the quality of service is not hindered by that. The securing a network involves many protocols, technologies, devices, tools, and techniques in order to secure data and mitigate threats. Threat vectors might be external or internal. So external threats could be like, something coming from the internet, and internal threat could be someone inside your network trying to gather data, or an infected device inside your internal network is trying to gather data. It can be considered as an internal threat. So external threat, as I mentioned, those are coming from outside. They could be viruses, worms and Trojan horses, spyware, adware, zero-day attacks, threat actor attacks, denial of service attacks, data interception and theft, and identity theft. I will not go into depth of each one of these different external threats in this particular module, but I will post another video on these external threats and internal threats later. So the internal threats could be lost or stolen devices, such as a USB drive, accidental misuse by an employee. Let's say your employee accidentally install a software that is spying on your company, and employees who may have intention of harming your organization. So those can be considered as internal threats. The security solutions for those external and internal threats can be implemented in multiple layers using more than one security solution. Network security components for home or small office networks can be antiviruses and anti-spyware software that can be installed on end devices. Intermediate devices such as routers can have firewall filtering built into it, or you can have a separate firewall device that can be used to block unauthorized access to the network by monitoring ports as well as users. Large networks have additional security requirements, such as a dedicated firewall systems, as I mentioned. Those are such as like the Palo Alto firewalls, for example, or Cisco dedicated firewall appliance. We can use access control list. Again, we will not go into any depth into what are access control lists in this particular module. Intrusion prevention systems and virtual private networks, or VPN. All of these different areas I will discuss in depth in separate videos, and because this is just the introduction to networking module, I will not go into depth of those. The study of network security starts with a clear understanding of the underlying switching and routing infrastructure, and also understanding what are these threats and identifying them. Finally, we will talk about the IT professional, which is you. as you finish these CCNA, CCNP courses and obtain those certifications, you become the IT professionals. CCNA or Cisco Certified Network Associate certification demonstrate that you have a knowledge of foundational technologies. It ensures you stay relevant with skills you needed for adoption of next generation technologies. CCNA focus on IP foundation and security topics, wireless, virtualization, automation, and network programmability. The new DevNet certifications at the associate, specialist, and professional levels to validate your software development skills allow you to demonstrate to your employers that you can, you have the specific knowledge and the understanding of those particular concepts. In terms of networking jobs, you can check it out on the NetAcad website and you can see the employment opportunities. You can search on your local websites and local companies and see what kind of opportunities you have in the networking field. And you should be able to find opportunities by using Talent Bridge matching engine by Cisco, for example. And because this slide set is provided by Cisco, I understand it's one of the things that they put it into this slide set, but I also found it's pretty helpful. Like, you can go and check it out. And there are also Cisco Network Academy students and alumni connections that you can make on their website. So if you are registered in the CCNA program for this particular course, you should be able to do the module practice and the quiz. And what you need to remember as a summary is that through the use of networks, we are connected like never before. All computers that are connected to a network and participate directly in network communication are classified as host. Diagrams of networks use symbols to represent the different devices and connections that make up a device. And remember those two different types of diagrams, logical diagram versus the other one. Diagram provides an easy way to understand how devices connect in a large network. The two types of network infrastructures are local area network LAN and wide area network WANs, and how they are different from each other. You should know that. SOHO internet connections include cable, DSL, cellular, satellite, and dial-up telephones. Business internet connections include dedicated lease lines like T1 lines, metro internet, business DSL, and satellite. And the other things we learn is the network architecture refers to the topologies that support the infrastructure and the program services and rules or protocols that move data across the network. There are 4 basic characteristics of a network architecture, which is fault tolerance, scalability, QoS, and security. And make sure you know each one of them in detail. Recent networking trends includes things like bring your own device or BYOD, online collaboration, video communications, and cloud computing. And know what they are and some of the examples that I mentioned. There are several common external and internal threats to network, and identifying those threats are very important. Larger networks and corporate networks use antiviruses, anti-spyware, and firewall filtering, but they also have other security requirements such as dedicated firewall systems, access control list ACLs, intrusion prevention IPS, and virtual private networks. You just need to know what they are, but you don't need to know in depth how they work. That is not part of this particular module. And the Cisco Network Associate or CCNA certification demonstrate your knowledge of foundational technologies. And when you obtain CCNA and also CCNP, you'll get these badges like I have here. These are the badges that I have, some of the badges that I obtained. And it shows that you learn the basics of network systems and apply the knowledge of the practical applications. Whatever you learn in this particular module, you can apply to your daily life. And you, like I mentioned, you can obtain the CCNA, CCNP certifications through doing this module with a registered organization that will administer these courses and exams for you. And that's everything for today. And I will be posting some other additional supporting videos in the future, as well as the new modules in this series. And this slide set was provided by Cisco. It is copyrighted to Cisco company. However, the information is free to use for educational purposes, and that's what exactly what I did here. And it is a very common slide set, as I mentioned, and we will look into the new next couple of modules in this particular series. But by listening to different people talk about different network administrators and professionals talking about this particular slide set will allow students like you to gain more in-depth knowledge of network systems by just understanding the same concepts try to learn the same concepts in different ways. And thank you so much. Please subscribe and thumbs up, and stay tuned for our next module that will be published in few days.